Okay, this problem would be a lot more difficult if you were required to use the disk method, but we're told to use the shell method. And when you use the shell method, you want your typical rectangles that are revolved about the axis of revolution to be parallel to the axis of revolution. So this is the axis right here, the line x equals 6. So we want our typical shells to appear in this region, which is the graph of the parabola y equals 4x minus x squared, above the x-axis. And this is the setup of the definite integral right here. When you use the shell method, it's 2 pi times the definite integral from a to b, in this case from 0 to 4, of the height of the shell. That's what this is, the height of the shell. So each shell, for some x along the x-axis, this height is 4x minus x squared. And then we want to multiply that by the average radius. That means the distance from the axis of revolution to the center of a typical shell, where this x coordinate represents the center of the shell. So to get this distance right here, well, let's do it for this rectangle right here. We want the x coordinate at the right, which is always 6, minus the x coordinate at the left, sorry. And that's this distance right here. So 6 minus x will give us this green distance right here. That's why this is the average radius. Now you can multiply these two binomials together, find an antiderivative, evaluate from 0 to 4, multiply that result by 2 pi, and you've got your answer. Okay, and let me get a copy of that. Whoop. Edit, copy, there we go. So if you do all that, you will see that your answer is 256 pi over 3 cubic units. Okay, we got a volume. Now it's, again, possible to solve this problem using the disk method. We would have to integrate along the y-axis from 0 to 4. And we would have to, for each y, come up with a formula for the distance from the axis of revolution to the outer portion of the shell. And that would be the outer radius squared, and then minus the inner radius squared. So we would have to solve this equation for x. And I'll post a link to a graph, Desmos graph, that shows you what that looks like, but it's a lot more complicated than using the shell method. So there you go. Hope that helped. If you have any questions, post a comment.